Assalamualaikum and hi everyone. Thank you for being here today. We are excited to present our work on high performance liquid chromatography or HPLC, a powerful analytical technique widely used for separating, identifying and quantifying components of complex mixture. We will explain in greater detail about the analysis of sugar using HPLC.
Assalamualaikum and hi everyone, my name is Najha. So I'm going to explain about the introduction of the topic. Sugar analysis is a crucial aspect of research and quality control across industries like food, beverage and pharmaceuticals. Sugar ranging from simple monosaccharides to complex polysaccharide. It is impact taste, nutrition and metabolism. To quantify sugar accurately, reliable techniques are essential. High performance liquid chromatography, or known as HPLC, is a widely used method for sugar analysis due to its exceptional sensitivity, resolutions, and the ability to separate multiple sugars simultaneously with a minimal preparation. By using advanced detectors like a mass spectrometry or a refractive index, HPLC delivers precise sugar profiling. In versatility makes it indispensable in a modern laboratories, ensuring that the product is diversity, regulatory compliance, and supporting scientific innovation. About the objective. The first one is to determine the retention time of a standard solution, and the secondly to determine the nutritional value of a food source or to assess the health impact of sugar, and the lastly to identify and quantify the amount of sugar in the sample. So that's all from me. Thank you.
So for the methodology, we start from the preparation of standard solution. To begin, we prepare a standard sugar solution by dissolving 2 g of fructose, 2 g of glucose and 0.5 g of sucrose in 100 ml of distilled water. Next, we create a working sugar mixture by mixing 1 ml of the standard solution in a 10 ml volumetric flask and diluting it to the mark with distilled water. Secondly, for the sample preparation, for the honey sample, we dissolve 2.5 g of honey in 25 ml of the ionized water. Then we filter the solution using a 0.045 micrometer nylon filter into a 50 ml volumetric flask. Then we transfer a small portion of this filter solution into an HPLC vial for analysis. Uh, for the HPLC condition, the analysis is performed using a Zorbeck's carbohydrate column with 150 times 4.5 mm. The mobile phase is 20:80 volume over volume mixture of distilled water and acetonitrile. The injection volume is 10 microliter with a flow rate of 1.5 milliliter per minute. The column is maintained at temperature of 27 Celsius and the detector used is a refractive index detector or RID. So, for the analysis and identification, both the standard and sample solution are injected into the HPLC system. Then the chromatograms of the honey sample are compared with the standard sugar mixture to identify peaks based on retention times. Finally, sugar concentration are calculated by comparing the peak areas of the sample with those of the standard.
Now let's dive into the result of high performance liquid chromatography. For component of HPLC result is divided by 4 components, which is chromatogram. A representative chromatogram is shown in figure 1 of the paper. It displays clear peaks for fructose, glucose and sucrose. Fructose peak appear at 7.8 minutes as seen in the graph. The second part is retention time. Fructose, glucose and sucrose peak in the chromatograms were matched to the retention time from standard sugar solution as seen in table 2. The third part is peak area and height. Peak areas correlate with the concentration of sugar in each honey sample. For instance, SH11 show the highest fructose content with 40.63 with a corresponding large peak as referred to the figure 1. The last component for HPLC result is resolution. Peaks in figure 1 demonstrate high resolution between fructose, glucose and sucrose, ensuring accurate separation and quantification. Now let's move on to the interpretation of results. For the first part is retention time, which is fructose retention time at 7.8 minutes aligned with the peak shown in figure 1. Then sample SH3 and SH12 shown sucrose peak confirming minor sucrose content as seen in table 2. For peak area and height, graph illustrate the prominence of fructose and glucose compared to sucrose. For example, SH11, fructose at 40.63% and glucose at 34.10%. While for SH7, the lowest fructose content at 29.08%. The third part is signal baseline. The chromatogram, for example in figure 1, shows a stable baseline reflecting proper instrument calibration and no interference. The fourth part is quantitative implication. The average fructose to glucose ratio was 0.2 across sample. It was calculated by the table on table 2. This indicating the stability and reduced crystallization happens. Now is analysis of sugar in honey of HPLC experiment. For the first objective is to identify and quantify sugar in honey using chromatogram, as shown for sugar peaks in figure 1. The second objective is to assess honey quality through parameters such as total sugar content in table 2 and fructose-glucose ratio. Second point is experimental details, which is retention time, peak height and area from chromatograms shown in figure 1 were used to quantify sugar contents. HMF present was analyzed via HPLC. Representative chromatogram for sample with and without HMF are shown in figure 3A and 3B. For the result, total sugar ranged from 50.26% for SH7 to 74.74% for SH11. Fructose to glucose ratio averaged 1.3, that's shown in table 2, and 4 HMLs detected in 10 samples below the 60 mg per kilogram limit, with 4 samples showing no detectable HMF, as shown in chromatogram in figure 3. As for outcomes, graph confirm compliance with international honey standard, which is called as limitrations and GSO, and no alteration was found, and most samples had high sugar content and low HMLs, ensuring the quality.
So for the discussion part, I will talk about with an average fructose to glucose ratio of 1.3, the HPLC analysis of honey sample show a considerable range in total sugar content, from 50.26% to 74.70%, suggesting good quality and a lower risk of crystallization. Chromatogram for fructose, glucose, and also sucrose display distinct, well-reserved peaks, guaranteeing precise sugar identification and measurement. A measure of honey freshness and heat exposure, we call HMF, or also known as hydroxymethyl furfural, was found in trace amount below the international limit of with 60 mg per kg. 4 samples had no detectable HMF. This result demonstrate that the honey sample are in line with international standard, free of adulteration, and also guarantee quality due to their high sugar content and low HMF level. So that's all from me.
In conclusion, high-performance liquid chromatography, or HPLC, is a widely used and highly successful technique for determining the sugar content in any liquid fruit products. It is high sensitivity and precision. HPLC guarantees accurate results even when analyzing complex metrics, making it ideal for a precise identifications and measurement of important sugars like glucose, fructose, and sucrose. One of the key advantages of HPLC is
It is ability to isolate various sugar components in a single run. This is minimize interference from other substances, ensuring that the results are both accurate and reliable to each other. As the result, HPLC serves as an essential tool for ensuring product authenticity, As the result, HPLC serves as an essential tool for ensuring product authenticity, maintaining high-quality standards, and complying with both legal and industry regulation in beverage sector. HPLC plays a critical role in preserving product quality, it is a key to maintaining customer trust by delivering consistent and reliable outcomes. That's all from us. Thank you.